Okay, so chapter 15 is on sampling distributions, and we're going to revisit some things that we've covered before. So we're going to start off with parameters and statistics. So a parameter is a number that describes the population. In practice, the value of a parameter is not known because you can rarely actually survey your entire population and find out that number. A statistic is a number that's computed from our sample, and we often use that as an estimation of our parameter. Okay. Parameters are fixed in value, and statistics will vary or change based on the sample that we choose from our population. Okay, so let's take a look at our classwork and get some practice doing that. Okay, so on your classwork, you have 3 examples, and you'll notice some bold-faced font in each example. You're going to decide if each one of these is either a statistic or a parameter. So it might be that in each example, they're both statistics or both parameters, or maybe one is a statistic and the other is a parameter. So you're going to go ahead and pause the video and give that a try. All right, so let's see if you came up with the same things. Let's take a look at this. Genetic engineering. Here's an idea for treating advanced melanoma, the most serious kind of skin cancer. Genetically engineer white blood cells to better recognize and destroy cancer cells, then infuse these cells into patients. The subjects in a small initial study of this approach were 11 patients whose melanoma had not responded to existing treatments. One outcome of this experiment was measured by a test for the presence of cells that trigger an immune response in the body. The mean counts of active cells per 100,000 for the 11 subjects were 3.8 before the infusion and 160.2 after the infusion. Okay, so since these came from our 11 subjects in our sample, both of these numbers are going to be statistics. Number 2, Florida voters. Florida played a key role in recent presidential elections. Voter registration records in February 2014 show that 39% of Florida voters are registered as Democrats and 35% as Republicans. Most of the other people did not choose a party. To test a random digit dialing device that you plan to poll voters for the 2014 Senate elections, you use it to call 250 randomly chosen residential telephones in Florida. Of the registered voters contacted, 34% are registered Democrats. Okay, so these first two, so voter registration records. So these would be all of the people registered to vote, which presumably would be all of the people who are allowed to vote in Florida. So this 39% and 35% should be parameters. And then you use this random phone dialer. So this is a machine that randomly dials phone numbers. And you randomly dial 250 phone numbers. And of those, 34% are registered as Democrats. That would be a statistic. So that comes from your 250 from your sample. So this is going to be a statistic. And the last one is on steroid use. Researchers surveyed 500 American anabolic androgenic steroid users ranging in age from 16 to 62 and found that 98.8% of them were male. The proportion of all Americans between the age of 16 and 62% who are male is 50%. The median age at which those surveyed who began using steroids was 22. All right. So of the 500 users, 98.8% were male. So this 98.8% comes from the 500, which is our sample, making it a statistic. It says the proportion of all Americans between the ages of 16 and 62 is 50%. So that's going to be a parameter because we're talking about the population of all Americans. And then we're talking about the age of those 500 who were surveyed. Their average start age for using the steroids was 22. So this is going to be a statistic as well because this is coming from our sample. All right, so I hope you are having a good grasp of statistics and parameters, and we're going to pick up with the law of large numbers next.